All right, so we have a problem with a nursery, and this is a fairly involved problem here. We got lots of things going on. We have different sized pots, and we have different ounces of fertilizer. It all depends on the temperature during the day. So there's a lot of things to consider on this one. But once we break it down into its parts, it's really not so bad. So the first thing they said is, well, the thing we want to find out first is what our output is. And really all they want to do, whoops, sorry, not that one. So we want to go ahead and open up a notepad file, and we want to put in our assumptions, our input, calculations, and our output. And all they want out is the total ounces. All right, so that's it. But the total ounces is based upon a lot of stuff. So one thing we're going to do is we know that this has to be a calculated value. So we're just going to go ahead and copy this and paste it up here. And that's going to be equal to, so what's the simple math to figure out the total ounces? Well, if I knew how many gallons of pots I had, each of the pots are different gallons, and I'd have to figure that out. So I'm going to say total gallons pots times whatever the rate is, and we'll call that the FERT rate. So if I know based upon all the different kind of pots I have, once I know how many total gallons of pots I have and I know what the rate is, I just multiply that together and that gives me my total ounces. Lot has to go on in order for me to figure out these two, but that is the basic math I'm going to have to do. Now on here also there's lots of low-hanging fruit, all these numbers, so we're going to have to put those numbers into our assumptions. And I'm going to cheat a little bit because I already have this somewhere else, and magically, boom. Okay, so these were all the different, temperature cutoffs, what each kind of pot, how many gallons are in each kind of pot, and then the three different rates of fertilizer we use depending upon the temperature. So all these are constants, so we go ahead and copy and paste them up there, and we're going to be using them later on when we do our math. So the first math what we can do is, well, let's figure out what the fertilizer rate is. And the fertilizer rate is dependent upon the mean temperature. So let's go ahead, we have to make a decision for that, and this is the decision we're going to make. We're going to say that if the mean temperature is greater than the high temperature cutoff, which is 80, we're going to use the high temperature rate. Then we're going to say, well, if the mean temperature is lower than the lowest rate, then we're going to use a low. Other than that, we're going to use a medium. Now, why did we test for the high and then the low and then whatever's left is medium? Because it allows us to do some simple calculations. If we were trying to figure out what the medium temperature in, we'd have to do a complex decision and say, well, if the mean temperature is greater than the low temperature cutoff, but also less than the high temperature cutoff. So that's a complex decision. And we try to avoid them at all costs because that just makes makes it harder for us to maintain our code, and we have a lot more errors. So the best thing you can do is when you're doing that type of thing, we're trying to find some middle values, is first try to find the high value to infinity and then the low value to the negative infinity, and whatever's left over is going to be the middle values, and that's going to be a good strategy for you. Also, we have else if. So if it's true, we're going to do that. If it's not true, see if this is true. If it is, then do that. If that's not true, then just do this last part. So we're going to be coding that a little bit later. All right, so now we have figured out what the FERT rate is. Now we have to figure out what our total gallons are. All right, and that is pretty easy because at least the math is not that difficult. And we've done this kind of math before in some other problems. All right, so the total gallons of pots, which is what we're going to use here, is equal to the small pots, how many gallons of small pots, plus how many gallons of medium pots, plus how many gallons of large pots. So once If we know these three values, then that value is easy. But we try to do this bottom-up methodology because we can get into the weeds pretty quickly trying to figure out what math to do first. So if I start with this and figure out what my FERT rate is, okay, that wasn't so hard. Then total gallons, how do I figure that out? But instead of trying to figure out all the gallon things first, I say, well, what's the math for that? And that's simply this. So now I just have to figure out how many gallons of each type of pot I have, and that's the number of those pots times how many gallons are in that pot. So not that difficult also of math, but and that's it right here. Right? So the number of large pots times the large pot gallons, and the large pot gallons is up here. So if I had 10 of those, 10 times 25 would be 250 gallons that I had in just large pots. So we're going to have to do this math here. Well, in order for us to do that math, we're going to have to know what is the number of small pots, the number of medium pots, the number of large pots. And that's something that's going to have to be provided to us. So we're going to have to, let me go ahead and get all of them. So I have to ask of someone what is the number of small pots, what's the medium pots, what's the large pots. And then because of this, I have to figure out, well, is the mean temp greater than? Someone's going to have to tell me what the mean temp of the day is. So that is also going to be our input. All right, so starting from the bottom, working up, figuring that this is the simple math necessary to get total ounces. Then we figured out the FERT rate depending on the temperature. So there's no math involved, it's just assigning the temperature to the FERT rate depending on what the temperature is. Once we know what the fertilization rate is, then we have to figure out how many gallons of pots, how many gallons we have of the pots that we own. And that's what this is. We said, well, the total gallons is the small pot gallons, medium pot gallons, plus the large pot gallons. And that gives us that. Well, how do we figure out these three? And that is the different size pots multiplied by the number of those kind of pots times the number of gallons those pots represent gives us all that. So a fairly involved problem here. Lots of numbers, decisions, and math. But once you break it down using the bottom-up methodology from here to here to here to here to here, then the solution reveals itself to you. Only 3 types of pots would be something we would want to ask our user. We're assuming that's true. And rate of FERT is based upon temp. Right? And they say, well, why are we asking that? They already told us this. Well, what if we said, okay, well, this is what's always true, but I don't ask that question. Then they run the program later on. They go, wait a minute, it's raining. What do you mean it's raining? Well, if it's raining, then we increase the fertilizer amount. Well, you didn't mention that in the paragraph. Well, you should have asked me. So this is where I'm saying that the rate of fertilizer is based upon the temp. And then they say, oh, well, if it's raining, then it's a different. So that's what we're trying to do with these assumptions, is try to figure out where we're assuming something. And then calc is done once a day. All right, and then we say, okay, calc done once a day, and he goes, yes, but I also want to know the weekly and the monthly. I said, well, you didn't tell me that. Well, you didn't ask me that. So by documenting what I'm assuming is true based upon that paragraph, I can make sure that I have the best solution. All right, I'm going to go ahead and skip the flow chart for a video, and I'm going to go and show you how to do the code in the video next.